All right, guys, yesterday we learned that the multiplication property, the product property, in other words, happens when two things are written next to each other. They could have like a dot in the middle, they could have a star in the middle, they could be next to each other in two sets of parentheses, all right? So either way, two things that are next to each other. So this example is an example of the product property because you've got two sets of parentheses next to each other. The product property says we multiply coefficients, keep the base, add the exponent. So coefficients are the numbers in front of the variables. So I'm going to multiply 4 times 9. Base in this case is the variable itself, which is x. So I'm going to keep that the same. And then I'm going to add the exponents together. This does not equal 13/9. All right, so when you are adding exponents together, use your calculator for that. So I'm going to do 2/3 plus 11/6. I don't have my calculator pulled up. I got it right. Okay. And then I'm just going to math enter to simplify the fraction. Forgot I restarted my computer. All right, so to do this math in the calculator, you're going to just do 2 divided by 3 plus 9 divided by, what was the other denominator? 6? So 2 divided by 3, 11 divided by 6. Thank you. 11 divided by 6. All right? And if you get a decimal when you do that addition, you want to math enter that. So we've got 5/2. So this all becomes in exponential form, 36x to the 5/2. We call that exponential form because there's an exponent. If in exponential form your exponent is a fraction, then you also can write something in what's called radical form. That exponent, that's the fraction, belongs only to the x. It's not touching the 36. So the 36 is just going to kind of hang out in the front. The x is what's going to be able to be written inside of the root. So the top of that x, 5, is in the inside, and the bottom is in the outside. Before break, we learned that if the number inside is bigger than the number outside, then there's more that we can do. We want to think of things multiples of 2, right? So 2, 4, 6 is too much, so we'll use 4. Which means this one's going to have to be a 1 so that together they add up to be 5. Well, 4 goes into 2 twice. I just can't forget that there's going to be an x with that. And when the inside number is smaller than the outside number, that's how we know we're done that part of the problem. And then the 36 just comes down. So 36 x to the second square root of x is what's considered radical form because there's a root there. Exponential form, radical form. Both are answers to this problem. You needed both. Today we're going to do the other two properties. We talked about those properties yesterday. So we talked about the division property and the power property, but we did it with whole numbers as the exponent. So today we'll do it with fractions, which really won't be that much more difficult because the calculator handles the fractions for us. We just have to know how to put them in. So you need your workbook today, keep that out, but you also need your toolkit. We're going to finish the toolkit today. We're just about done this unit. Quotient is a fancy way of saying division, so it might be helpful for you to jot the word division with this. Because you might read quotient in a few weeks and be like, what does that mean? So the quotient means division, all right? The division property of exponents says that we divide and sometimes simplify the coefficients. We keep the base and we subtract the exponents. you'll know it's a division problem. It's pretty obvious looking. It's like a really big fraction, all right? So we are going to divide coefficients, keep the base, and subtract the exponents. What is a coefficient? What is it? A whole number. It could be a fraction though. A coefficient is a number in front of a variable. Coefficient is a number in front of a variable. So when you don't have a variable, you don't have a coefficient. 32 is not a coefficient. Do not do 32 divided by 32, okay? Because this 32 has an exponent on it, now it's called a basement. It's a base, okay? So it's not a coefficient, it's a base. We keep the base the same. The 32 is going to stay a 32, all right? Keep the base the same. It would be a coefficient if it was like 32x to the 3/4, and there was like an x in the middle, all right? So we're going to keep the 32 the same. And we're going to subtract exponents. So we keep base, subtract exponents. I'm not going to do 3 minus 1 is 2, 4 minus 2 is 2, therefore 3/4, 1/2 is 2 over 2. That's not the way subtraction works with fractions. Just pick up your calculator and do the math in your calculator. 3 divided by 4 minus 1 divided by 2. If you get a decimal, you should math, enter that decimal. And so I get 1/4. 32 to the power of 1/4. Now before I circle that as my final answer, I want to check it in the calculator because it could be a whole number, right? So if it's a whole number, I want to change it. But in exponentials, if you get a weird decimal here, then you leave it as is. So I'm just going to check this in the calculator. 32 to the power of 1 divided by 4. And it's a decimal, which means I am going to leave it as it is. So exponential form is this. If exponential form has an exponent and that exponent is a fraction, then you can also do radical form, meaning we can write this as a root. The base, the bottom number 32 stays on the inside. The 1 is the inside, the 4 is the outside. What is 32 to the first power? Still just 32. When we simplify roots, and those roots are numbers, not variables, we first go to math 5, and we see if it simplifies to a whole number. And you'll see this is not 8, right? It's a decimal. Now, with exponents, it's cool to leave it like that. But with roots, we got to break it down. So now I'm going to go to the y equals screen, and I'm going to do 32 divided by x. What I am looking for in my table is a perfect 4. In the perfect 4 list, there is a 16, and then the next number is 81, so it's definitely not that. So I see a 16, right? 16 is a perfect 4, and it is in my table. So I'm going to use 16 and the number next to it. To break up that 32. And then I would math 5 each of them and see what they become. The 4th root of 16 is not 4, it's 2. And the 4th root of 2 is not 1/2. It's also not 2. It's a long decimal, which tells me to leave it like this. And this is called radical form. Division property. Divide coefficients, keep the base, subtract the exponents. So in this case, if coefficients are the numbers in front of the variables, I have a variable, but I don't have a number in front of it. So there are no coefficients in B either. So I'm just going to work on keeping the base and subtracting the exponents. 10/3 minus 2. I don't have to be able to do 10/3 minus 2 because my calculator can do 10/3 minus 2. If you get a decimal when you do that, you should make it a fraction. So my exponential form is x to the 4/3. If exponential form has an exponent and that exponent is a fraction, you can also make radical form. Inside is the numerator, outside is the denominator. And when you're working with variables, if the inside exponent is bigger than the outside exponent, you've got to split it up. What multiple of 3 should I use? 3. Which means the other exponent would have to be 1. 3 goes into 3 one whole time. I just can't forget about the x. 1 is smaller than 3. That tells me that I'm done here. I'm just going to rewrite this answer without the 1s. You can write the 1s, you just don't have to. So radical form is x 3rd root x. We okay so far? All right, now example C and D have coefficients. They have variables and they also have numbers in front. So we're adding in the first step. Divide / simplify the coefficients. So for example C, that's 6 divided by 3. That's 2. Keep the base. Subtract the exponents. 6 minus 1/4. If you type that into your calculator, 6 minus 1/4, you get 23/4. So that's my exponential form. And there is a fraction, and that fraction is an exponent, so I must have a radical form too. That exponent that's a fraction only belongs to the x. So therefore that 2 in the front's just going to stay in the front. I'm not putting it inside the root. It would need its own fraction to go in there, and it doesn't have one of those. Since 23 is bigger than 4, I'm going to have to split this up. What multiple of 4 should I use? I like 20. So I'll use 20 and then 3. All right. 20 goes into 4 5 times perfectly. And I don't want to forget that there's an x there. And 3 is smaller than 4, so that means that part of the problem's done. And there's this 2 that just kind of keeps coming along. This is called radical form. Everybody okay so far? All right, the only thing that makes the next one different, well actually there's 2 things that make the next one different. One, when I go to divide the coefficients, 4 divided by 6, I don't get something that's nice, right? It's not a clean 2 like the previous one was. So 4 divided by 6 is a decimal, but we don't want to write decimals on our paper. So instead I'm going to math, enter that. So I'm going to call that 4/6 a 2/3. I'm going to keep the base the same. I'm going to just write it off to the side. You could also write it in the top. So your options are top or side, not bottom. All right, top or side. And now I'm going to subtract exponents. Here's another part that's different because I've got an exponent in the top, but I don't have one in the bottom. What should I put? 1. When there's not an exponent there, we put a 1. So we're going to subtract 87/7 from 1. (81/7). 81/7 from 1. So 74/7. My exponential form is 2/3 to the 74/7. Now this part might be a little tricky because normally I say how many fractions are there, and then that's how many roots there are. There are actually 2 fractions here, but there's only 1 root. That 2/3 isn't an exponent, right? The fraction has to be an exponent to be a root. So even though I have a fraction here It's just a coefficient fraction. This is the one that makes the root. So this 2/3 is just going to stay at 2/3 the whole way through, all the way to my answer. This is the part that's going to become a root. What multiple of 7 should I use here? 70. So that means this is going to be a 4, and again, still just 2/3. So 70 goes into 7 10 times, so we'll call that x to the 10. And then 7th root of x to the 4th is going to stay as is, and so is the 2/3. So my final radical form looks like that. The quotient property. The only thing that's different here than what we did for the warm-up, than what we did yesterday, is the first step. I changed the plus to a minus. Everything else is the same. The same stuff. Okay, just know that if you're dividing, this is a subtraction. Whereas if you're multiplying, it's addition. All right, we're going to do a quick practice. You're going to try the problems at the top of page 21. At 146, I'm going to post the answers. Okay? You can work together. You can work on your own. I wouldn't suggest moving desks around because 6 minutes is going to go fairly quickly. But do what you got to do. All right? 146. I will post the answers for these 3 problems. This is the last toolkit entry we're going to do for the unit. This is it. All right? You can write skip for D. We are going to do A, B, and C. We are not going to do any of the other problems on this page. We're going to keep it really basic, okay? The other problems are a combination of rules, which I think that's more of an extension than something we need to take notes on, all right? We're going to do the power property straightforward. The power property could come across like the multiplication property because you're going to see some parentheses, but there's nothing like next to each other. That's multiplication. This is just one set of parentheses, only one thing. So it's called the power property. In the power property, we raise the coefficient, we keep the base, and we've multiplied, or sorry, we've added, we've subtracted, and now we're going to multiply the exponents. We do everything but divide exponents. That would just be dividing fractions. Right? So, coefficients are numbers in front of variables. In letter A, there's a variable, but there's no number in front of it. So there is not a coefficient in letter A. I'm going to go right to keeping the base the same and then multiplying the exponents. All I have to do is do 3 divided by 2 times 3 in the calculator. You don't have to use parentheses or anything like that. It's just 3 divided by 2, which is the first fraction, times the second part is a 3. If you get a decimal, change it to a fraction. All right, 9/2. So my exponential form is a to the 9/2. Where there's an exponent that has a fraction, there's a root. So I can write this in radical form. The top stays inside, the bottom goes outside. Because the inside's bigger, I'm going to split this up. So I want to be thinking about multiples of 2. 2, 4, 6, 8, 10 is too much. So I'm going to use the one right before that, which is 8. And then this one will have to be a 1, so I keep that value of 9. 8 divided by 2 is 4. We just can't forget about the A. And when the inside's smaller than the outside, we leave that part alone. I'm just not going to write the 1. So this is called radical form. This is called exponential form. The next one is another power property problem, but now there's a coefficient because there's an x, and then in front of the x is a 12. So I'm gonna raise the coefficient to the power. That's what that means. It's like 12 to the power of 2/3. Keep the base and multiply the exponents. I'm not doing 1/2 to the power of 2/3. I'm doing 1/2 times. I'm multiplying the exponents. I am gonna check this. With exponential form, we like to check this because if it's a whole number, I can change it. But with exponential form, if it's a decimal, I can just leave it as is. So it just depends on what I get. So it's 12 to the power of 2/3. It's a decimal. So I'm going to leave this as 12 to the power of 2/3. And then I'm going to do 1/2 times 2/3. 1/2 times 2/3. Math, enter, enter. 1/3. This is called exponential form. In this exponential form, there are two exponents that are fractions, so there are two roots. 12 gets its own root, and x gets its own root. The numerator is the inside, the denominator is the outside. What would I do next from here? What's the next step? Raise 12 to the power of 2. I want to make that a number, so I'm going to call that 144. And because that's a regular number, under a root, we math 5 it first, and if math 5 doesn't work, we y equals it. So I'm going to math 5 it. And when that doesn't work, I'm going to y equals it. And I'm looking for a perfect 3. So if I'm looking at 144, the biggest possible 3 would be 125. That's below 144. I don't see that. The next biggest possible 3 would be 64. I don't see that. The next one would be 27. I don't see that. And the last one would be 8. That might be it. I just don't see it. So I got to go down my list a little bit. And eventually I see that there's an 8. And next to the 8 is an 18. So I'll go 8 and 18. The third root of 8 is 2. And the third root of 18 is not 6. If you type the third root of 18 into math 5, it's still just the third root of 18. What should I do with the third root of x to the first? Leave it. So I'm going to just throw it inside here with this. You can't simplify the third root of x to the first. All right, you guys try C. It's super similar to B. I'm going to give you a minute or two to give that one a shot, and then we'll go over it. So 8 to the power of 3/4 m to the power of 5 times 3/4. I'm multiplying the exponents. When you did 8 to the power of 3/4 in your calculator, did you get a whole number? I'm seeing a no. All right, so I'm going to leave that as is. What about when you did 5 times 3/4? What'd you get for that? Pardon? All right, so we've got our exponential form. And our exponential form has 2 fractions. So our radical form has 2 roots. What's 8 to the 3rd power? 5/12. Okay. So at this point, you would have tried to find perfect 4s that went into 5/12. Did anybody get a chance to get to that point? 5/12 divided by x in the y equals 3? What'd you get? I like 256, 2. And what was the 4th root of 256? 4. All right, so 4th root of 2. Yes? All right, what about splitting up this m to the 15th? What multiple of 4 did you use? All right, so 12 and 3. So 12 divided by 4 would give me 3, and then I'd keep the 3 inside. So my final radical form would be 4m to the 3rd, 4th root of 2m to the 3rd. I'm taking the stuff on the outside and writing them together, and then the stuff on the inside, I'm writing them together. All right, the last thing we're going to do today is try one of each property. I'm going to give you 10 minutes to do that, and then the last 10 minutes of class, I want to have to post the answers. So you're going to do the 3 problems on page 27. One is multiplication, one is power, one is division. I have the rules posted on the board so that you don't have to flip back and forth through your toolkit, but you totally can. After you simplify the exponent property, if there's a fraction that's an exponent, you also have to do radical form. You'll see a blank for both of them. All right, so at 2:08, I'm going to post the answers. All right? All right, so this is power property. I'm going to raise the 16 to the power of 2/3 and multiply the exponents. When you type 16 to the 2/3 into your calculator, though, you get a decimal. So I'm going to leave that fraction when I write it in exponential form. Because there are 2 fractions here, there are 2 roots. So I had to simplify a 256 and an x to the 16th. For the 256, I picked the perfect third of 64, which got me this 64 and 4. And for the 16, I picked the multiple of 3, that was 15. 15 and 1. So mix and matching my final answer, I get 4x to the 5th, 3rd root of 4x. Anybody need that up still? All right, next one. Divide 20 divided by 15. Math, enter, enter. I get 4/3. Subtract the exponents. 10/3 minus 3/7. I got 67 over 7. Now, I have my 4/3 like kind of within it, but you can write it in front too. You know how the other ones we were writing it in front? I just did this so you could see another format. They're the same thing. Having 4/3 in front is fine. Putting it with the x is fine too. There's only one fraction here, so there was only one root I was working with. And I chose to split it into 63 and 4. So ultimately, I ended up with this. Now, the 4/3 could be in the front, and you could call this 4/3, and then next to it, x to the 9th. 7th root of x to the 4th. That does not matter, the format of that. We okay with this one? All right, last one was a little tricky because even though the 2's are in front of the variables, they do have their own exponent, which makes them bases. So you're not going to do 2 times 2. You're going to keep the 2 and 2. And you're just going to add the 2 exponents and add the x exponents. The only thing that would change is what you typed in the calculator, and either way, it wouldn't simplify. From here, I have 2 fractions, so I have 2 roots I've got to work with. And this was my final radical form for this one. When you come in on Monday, we're just practicing all day. No new stuff. We're done the toolkit, all right? So practice Monday. Review all unit. Tuesday, test on Wednesday. So that's a layout for your next week.